Hello again, my name is Gene. I'm a new mentor for high school robotics team FRC 714, and today we're finally writing, or I should say copying, Python code for Swerve Drive drivetrain. Let's get to it. We have this Swerve Drive robot generously provided by a competitor team 8630, but we have to hurry because tomorrow they're taking it away for their driving practice. For this example, I took the code from Rev examples of RobotPy, but we have made a few modifications which proved quite useful during the competition, and we'll talk about this. So, without further waiting, here is the link on GitHub, and it's in the description of the video that you can use. Let's open PyCharm. I'm using the free community edition for this. In PyCharm, you can close the existing project if you have it open and hit Get from VCS. It's this button, Get from VCS. And the link to the repository with the example code goes into the URL field in here. We hit Clone, which means download. So with the code downloaded, what we have to do is we first have to set up a Python interpreter. We click on the lower right corner and we say add new interpreter. We're going to add the local interpreter based on, in my case, based on Python 3.9, because that's what I have installed. But you can pick whatever you have installed. It should mostly work. Between 3.9 and 3.12, it should be fine. The virtual environment is created. Now what we can do is we can go to the requirements file and make sure the requirements are downloaded. For example, RobotPy. Oh, RobotPy is not installed. We're going to install all the missing packages by clicking Install Missing Packages and hitting Yes, and the missing packages are going to get installed. Fantastic, the missing packages are installed. Alright, and finally, after everything was installed, we have this button, Sync, in here. This will download various dependencies that are needed by this type of robot. What are those dependencies? We can go to pyproject.toml to see. So here we're going to be using Navex for gyro, and I totally recommend Navex. It's great, it's precise, and it mounts directly to RoboRio, so it will always communicate with your RoboRio so long as the screws don't fall off. Rev, we need Rev as a dependency because we're using Rev motors and Rev Swerve modules, Max Swerve. Whether you like them or not, we're going to be using them right now. So by clicking Sync, we make sure that the code for all of this is downloaded. The code is downloaded. Finally, before we deploy the code on the robots, we can actually run it in simulation. And that's great because you can run it with a debugger, like this, by hitting the debug button. So I'm running this code in simulation, and hey, a very simplistic robot simulation shows up. Here I have my joystick in my hands, and it is connected. It shows up in here as an Xbox controller. I can click and drag it into joystick number 0. Normally we want joystick number 0. Now if I start moving the sticks on it, you can see the axis of the joystick number 0 moving. If I switch my simulated imaginary robot into teleoperated mode, as I did in here, we can check the state of different motors. For example, motor number 1. What's going to happen in simulation to robot number 1 when I start moving the sticks? Oh, look at this. The velocity of motor number 1 is changing. This is great, right? Because what we can do is we can then place breakpoints in the code of our subsystem, for example, here or Max Swerve module, and we can troubleshoot if something isn't working the way we wanted. For example, this one, set desired state. Oh, we have hit a breakpoint right now, and we can check, oh, the desired speed was 0. Great, great. And we can go through the code step by step by hitting this button, step over, step over, step over to understand what robot does when nothing is pressed, for example, on the joystick. You can see it just exited from that function. So simulation is a very useful debugging tool. I'm going to exit the simulation, and now we're ready to deploy this code on the robot. I'm going to switch to the deploy command, and we are going to run it. So in order to be able to deploy the code to the robot, we have to connect to robot's Wi-Fi, or we can connect to it using a network cable or printer cable, totally up to you. I'm connecting over Wi-Fi right now. Once we are connected, we can just hit this deploy button, deploy, and look at this, the code is about to deploy. All it needs to know is it needs to know the team number, because when it knows the team number, it can come up with the address of the robot, the IP address, based on the team number. I hit the team number, and the code is getting deployed to the robot. Fantastic. What we can do is we can make sure now if we can drive this robot. I'm going to start the driving station, FRC drivers. Make sure that your team number in here is specified correctly. Click here, make sure the team number is correct. If the team number is correct, all of these lights are supposed to be green because we are connected to the robot. I switch it to the teleoperated mode. I take my joystick, which we can make sure is connected by clicking the joystick tab, and here, look, I'm moving the sticks, the joystick is connected, and let's see if I can drive the robot in teleoperated mode. All I have to do is I have to push this enable button. Robot is enabled, and it can drive. Alright, so what I would like to show you next is odometry. Odometry is the idea that robot can count how many revolutions each wheel has made and which way it is heading, and based on this it can compute where is it on the field. Odometry is calculated by this drivetrain, and it's available in smart dashboard, so you can actually see what the values are, the X of the robot on the field, the Y of the robot on the field, and which way is it heading. Is it heading straight north, heading of 0, or maybe a little bit to the right, or a little bit to the left. What I'm going to do right now is I'm going to start driving this robot, but you watch the coordinates in here. X, Y, and the heading. First, I'm going to make it turn left. The heading is changing. It's now, I'm sorry, turn right. It's plus 30. Turn left, minus 25 degrees. The robot was turning. Now I'm going to drive it forward. The X is changing. Now I'm going to drive it to the side. The Y is changing. Going back and to the side. Perfect square. We're back to the origin, more or less. Finally, it's time to switch to the autonomous mode. Here in this code for autonomous mode, we have an example of a trajectory command, a curvilinear trajectory for the robot to move from point A to point B by doing a curve between them. It's pretty nice. I'm going to hit enable. Let's see what happens. Today I showed you how to download and make work an example of a Python code for FRC Swerve Drive with odometry and with autonomous trajectories. Thank you for watching. Next up, we're going to start looking at adding a manipulator to it, and then a limelight camera.